Welcome, my dear learners. In today's lesson, we shall be looking at the derivative of general logarithmic function. General logarithmic function. Remember, in our previous lesson, we learned how to find the derivative of natural logarithmic functions in the form of ln of g at x, where g at x is a function of what? X. In today's own, we are going to look at what? The general form of that. The general logarithmic function is of the form this very part we have log of x with the base of a, where a is the base of the logarithm function. The expression this is read as the logarithm of s with a base of what? A. And then let's look at the examples of general logarithmic function. Now when you have the function f at x which is equal to log x to the base of 3, this is an example of general logarithmic function. But remember, we learned in our previous lesson that the natural logarithmic function, they are function with a base of what? E. So when you have any logarithm function with a base of e, then we say that that function is what? A natural logarithmic function. And that is a typical example is what? Ln x or log s to the base of what? E. But with this one, we are looking at what? The general one, which is what? To the base of a, where a is what? A constant. Good. So we have another one. We have the function y, which is equal to log of s squared to the base of what? 8. So all these are classical examples of what? General logarithmic functions. Now that we know what general logarithmic functions are, how then do we find the derivative of these functions? So given the function y, which is log of x to the base of a, then we can say that its derivative is given as, we find the derivative of the x function all over the x function, and then we take the length of the base. I believe you know where the base is. Now the base is what? The a, which is the 5, the 3, the 8, and then the 7. So we differentiate the x function here, or the x variable here, the x variable, the x variable, the x function here, all over the x function. Then we take what? The length of the base. Very, very simple. That is how we find the derivative of general logarithmic function. Remember, with the natural logarithmic function, we take the derivative of the inside function all over the inside function, and then we are done. But with this one, we take the derivative of the inside function all over the function, then we add the length of the base to it. So you have to know the difference between that. If you have forgotten, you can go back to my previous video and then you watch it to get the clear difference between them. So we take examples and then we see how best we can apply them. So we have the first example. We have the function y, which is giving us log of x to the base of 3, and then we have to find the derivative of this very function. It's very, very simple. So you know that the derivative of the general logarithmic function is giving us this. So we identify our x, we differentiate it all over our x, and then we take the length of the base. So we know that our base here is what? 3. So we can see that the base is 3. So we have our base to be 3. So we take the length of that, the length of the base we are having what? 3. So you can see that our derivative y prime at s of this function, we are going to have, we differentiate what? The x function all over the x function, then we take the length of the base. Now the length of the base we have what? 3. Now what we are going to do next is to differentiate the x. Now when we differentiate x, very simple, we are getting what? Yes, we have 1, and then all over x length of what? The base 3, and this becomes the derivative. You see how simple it is. Very, very simple. But when you see the question, you might think it is difficult. We take our next example. So we have our second example. We have to find the derivative of this very general logarithmic function of this very form. So going through the same steps, we have our derivative y prime at x. So we differentiate what? The x function. So we have this all over the x function, and then we take the length of the base. The base is what? 7. So we are going to get, when we differentiate x, we are going to get 1. We have the x and then the length of the base, which is what? 7. And then you are done. Very simple. Just two-way steps, and then you are done. Take our next example. So we have our third example. You can pause the video and then you try your hands on it. Okay. So with this one too, we are just going to go through the same steps. You find the derivative of x, the x function, all over the x function, and then we take the length of the base. Very, very simple. So we know that our derivative y prime at x or x prime at x is the same thing, is giving us, so we have taking the derivative of the x function, which is what? X power 2 all over what? The x function, which is what? Squared, s squared. Then we take the length of the base, and we know that our base is what? 3. Good. Now when we differentiate s squared, power rule, we are getting what? We have 2s. Good. And then we have s squared length of what? 3. Very simple. We can just do some little simplification here. Now we know that this s will cancel one of the x, so we'll be left with what? 2 over x length of what? 3. Very, very simple. I believe you had the same answer that I got. You try the next example. But with this same question, we can apply the properties of logarithms. Okay, so we can bring this 2 in front of the log here, so that it will be 2 log of x to the base of 3. Then we treat log of x to the base of 3 as what? As 1. And then the answer that we are going to have, we multiply it by the 2 outside. We are still going to arrive at the same answer. So you can try that. Okay, so we have our fourth example. So looking at this question, what comes into your mind first? Now you can see that we have two functions multiplying. We have a polynomial function s squared, and then general logarithmic function of log of s to the base of 4. There are two functions all multiplying. So we can apply what? The product rule. I believe you remember. If you have forgotten, as I have been saying, go back to my previous videos and then you can watch them there. So we identify our u as this and our v as that, and we know that the derivative of product of two function is giving us, we have u v prime plus u prime what? V, where u prime is the derivative of what? U, and v prime is the derivative of what? V. So let's identify our u. So we say that our u is equal to what? S squared. Good. And then our v is equal to log of x to the base of 4. Good. Then after that, you find the derivative of our u, which is this one, which is u prime. So when we differentiate to x squared, we are getting 2x. And then when we differentiate log s to the base of 4, we know that our derivative will be giving us, we have the x of the x function all over the x function, then we take the length of the base, which is what? 4. So when we differentiate x, we are getting 1 all over x length of what? The base, which is 4. So now that we have the functions and their respective derivatives, we just what? Substitute them back into the product rule formula. Are you okay? Okay, so let's continue. So we have our y prime at x, which is giving us now u. Where is our u? This is our u. So we have x squared multiplying v prime. So this is my v prime. We have 1 over x length of 4. I think we are done with this one. Then we have plus u prime. So our u prime is what? 2x multiplying v. Where is v? Our v is this very part. We have log of x to the base of 4. Now let's do a little bit simplification here, and then we are good to go. x squared times 1, we are getting x squared over x ln of 4 plus 2x multiplying log of x to the base of what? 4. You can leave your answer here or you can just simplify. This x will cancel one of the x at the numerator. So we are going to get, let me write the final answer. So we have y prime of x. I believe you can see. So we are getting x over ln of 4 plus 2x multiplying log of x to the base of what? 4. And this becomes the derivative of this very function. Very good. So we have a very nice example here that we are to solve. We have the function y, which is equal to 5 power x multiplying the log of x to the base of 4 plus a linear function 2x. We have to find the derivative of this very function. So what we are going to do is we are just going to differentiate them term-wise, but we have two functions multiplying. We are having we have a general exponential function multiplying a general logarithmic function. So we are going to treat that too as what product rule, and then we treat this also as a single or a term, and then we differentiate them. So we are just going to differentiate them term wise. So here we go. So we can say that our y prime at x is giving us differentiating 5 power x and then log of x to the base of 4, and then we differentiate our 2x. This is what we are going to do. So we are going to treat this as product, and we know that with the product rule we are going to use our u v prime plus u prime v. So we first have to identify our u and then our v from this very part. We are going to solve this first. So we let u equal to 5 power x and our v is equal to log of x to the base of what? 4. So we can say that our u is equal to, and then our v is equal to that. So we have derivatives here, so we have to find the derivative of u and then v. So the derivative of u is giving us what? U prime. And from our previous videos on general exponential function, what we are going to do is what? Yes, we can remember as we repeat the function, we find the derivative of the exponent, and then we take the length of the base. If you remember, so it says that we repeat the function. So the function is 5 power x. We take the length of the base. The base is what? 5. And then we differentiate what? The exponent. Good. So at the end, our u prime will be giving us 5 power x, length of 5, and then when we differentiate x, we are getting what? 1. So this becomes the derivative of what? U. Now let's move on to the derivative of what? V. So v is a general logarithmic function. So all what we are going to do is, so our v prime will be giving us, so we have we differentiate what? The x function all over the x function, and then we take the length of the base. So we are getting the derivative of v to be, when we differentiate x, we are getting 1 all over x length of what? 4. Good. Now that we have the function u and the v and then its derivative, we can substitute back to the product rule formula. So we are going to get, so this very part, our u is what? 5 power x. Our v prime is what? times 1 over x ln of 4, then plus u prime. U prime is 5x ln of 5, and then our v is giving us what? Log of x to the base of what? 4. Good. So let's simplify these very parts. We are going to get 5 power x times 1. We have the same thing, all over x ln of what? 4 plus 5x ln of 5, and then we have log of x to the base of 4, and this becomes the derivative of these two functions. We are now going to move on to what? The derivative of 2x, then we add it together, and then we are done. Very simple. So we know that when we differentiate, so let me add plus, this is the plus, and then when we differentiate 2x, we are getting what? 2. So this becomes what? The derivative of this whole function. You see it huge, but it is very simple. So I'm going to give you one example and then you try your hands on it, and make sure you write your answer in the comment section, and I'll be responding to your answers. So this is your try question. Let's take it as an assignment. Make sure you try your hands on it and you write your answer in the comment section. I'll be attending to you. Thanks for watching. Bye bye.